Hello, Math Analysis. This is section 5.2, the traveling salesperson problem. The beginning I'm going to go through kind of quickly. It's just a bunch of information about this problem in general. We started with the class opener, so you should try this on your own, put this on pause, and the answers will follow. So here you go, a review of what we learned yesterday. And you could always go back and watch the video from 5.1 if you didn't understand any of those. Okay, the problem of the traveling salesman is actually one of the most intensively studied problems in computational mathematics. It's studied a lot in computer science. So if you recall when we started section 4.1 with Euler circuits and paths, we were trying to find if it was possible to cross all of those bridges and return. This time, however, it's not just asking is it possible, but we want to find the shortest route. So what is this problem? So basically you have a salesman and he has to visit a number of cities and return to the city he started in. If you look down at the bottom here, we see that looking and knowing probability that there are a lot of possibilities for even just 10 cities. It's 3 million. So knowing that, we are going to want to be able to find a strategy that works well. Okay, so back through here, some of the slides about the computer science. I'm going to let you read through those on your own, so I'm just going to go through them kind of quickly. So the method that we're going to use is called brute force. And in brute force, basically what we do is we're going to make a tree diagram. And so I'm going to get us to that part. So first off, a weighted graph is a graph that has numbers on the edges. Here is an example of a weighted graph. So in the traveling salesman problem, you live in St. Louis, you need to visit the other 3 cities of Minneapolis, Chicago, and New Orleans, and you need to return home. So what type of route is this? Tell your partner or yourself, is it an Euler circuit path or Hamiltonian circuit or path? And did you say Hamiltonian circuit? Hopefully, because the cities are the vertices and you have to visit each one and return to where you live. So starting and ending at the same vertex makes it a circuit. All right, so we're going to try by guessing first. Why don't you take a look at that and see what you get? And did you get 2,530? Well, whether you did or didn't, I'm going to show you a more efficient way on how to do this problem. So it's called brute force, and we do it by making a tree diagram. So the things I want you to notice is this is the city you start in, it's St. Louis. And then notice that when the problem ends, you're also in St. Louis. So don't forget to end in St. Louis. Another thing you might notice is that when you're done, you're going to get 2 pairs of similar answers, and do you know why? If you take a look, it's just the same routes and they're the reverse of each other. So here's how we make a tree diagram. We start with St. Louis and we make that our very first point. And then we branch off into the 3 cities that we could visit first. Notice I put the numbers on the branches in the yellow. From there, then what I need to do is I need to choose to go to the other 2 remaining cities. So you could see those in blue. Now I only have 1 more city left to go, and you could see how those show up. And then finally, remember, I have to return home. So that is a tree diagram. It's called brute force. The shortest route then is the 2,530 miles. So we're going to try one together with this diagram. So why don't you try and let's develop it. We're going to start from vertex A. So do your first step, putting vertex A at the top, and write down your first set of branches. Did you get this? All right, now write down your second set of branches if you leave from cities B, C, or D. Did you get this? All right, now write down what the last city is that you would visit. Did you get this? And finally, remember, you're not done until you return home to the wife and kids or the dog and boyfriend. All right, here we go. And there we have our different routes. So now the final step would be to sum up all of those routes and make sure that we get pairs of opposite numbers, similar numbers. So the shortest route was ACBDA, or reverse is ADBCA. So we know that this method is only good for a few cities because it takes so long to do. So there is a second method that they came up with, and it's called the nearest neighbor. Now the thing about this method is that you're not guaranteed to always get the best answer, but you will get something close to the best answer. So here's how the nearest neighbor works, just like you would expect. So you start in St. Louis again, and you're going to go to the neighbor who is the closest. So Minneapolis is 550, St. Louis to New Orleans is 670, so we're going to choose to go to Chicago first. Now from Chicago, we either need to go to New Orleans or Minneapolis. So since Minneapolis is closer or cheaper, we're going to go there next. Now you have no choice but to go to New Orleans and finally to return to St. Louis. So when you're done, you get your answer. Notice it wasn't the best answer, but it was close. Okay, your turn. You're going to try one of these. So set the computer on pause and see how you do. All right. So we're going to review a little bit from yesterday. So see if you can come up with what it means for a graph to be planar. So a planar graph is a graph that can be drawn on a flat surface so that none of the edges intersect except at the vertices. Okay, bipartite. Draw one for me. So a bipartite graph is a graph whose vertices can be separated into two distinct groups so that the vertices in one group connect only with the vertices in the second group. This is an example of actually a complete bipartite. It's a K14. So now a complete bipartite means that every vertex in one group is connected to every vertex in the other group. And two graphs that are not planar we learned yesterday are the K5 and the K33. So we're doing an exit slip in class. You could try that out and see how you did. Our quiz is Tuesday. Here's tonight's homework. And homework problem number 1. This is the diagram. Make a tree diagram and do the nearest neighbor. Check your tree diagram. Did you get this? And using the nearest neighbor, did you get this? All right, ladies and gentlemen, we are done for today. This is section 5.2. Quiz is on Tuesday. Have a great weekend.